This morning in North Carolina, wheels are spinning. Determination is winning. A passion is now a thriving business, and it shows no signs of slowing down. How? The power of a conversation, like the one Clint Spiegel had with First Horizon Bank about starting a bike wheel manufacturing facility in Asheville. Now it's not just talk, it's rubber meets road. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Clint. First Horizon Bank, member FDIC. Recently, our client John met his banker to discuss plans for a clean energy building. What he found was a shared passion for building something more. Momentum for change. First Horizon Bank. Let's find a way. Go to firsthorizon.com/John.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello, once again, thank you for joining us. This is the Space Nuts podcast. My name's Andrew Dunkley, and with me, as always, is Professor Fred Watson, astronomer at large. Hello, Fred.
Hi, Andrew. How's it going?
Oh, good. I must confess, the last few days I've found myself getting a bit stir-crazy, being stuck at home and only going out when absolutely necessary, which is the directive of our government. But it takes a bit of getting used to. I suppose the first week or two it's a novelty, and then you start to realise it's not going to go away.
It's in for the long haul.
Yeah. Anyway, here we are. But it's a strange thing. I must say I am doing a lot of reading about COVID-19 and learning as much as I can. I find it intriguing. I know that probably sounds a bit morbid, but I just have this thirst for that kind of knowledge. So I've been really getting stuck into it and learning as much as I can. It's fascinating. And there's something else today, Fred, that we need to just briefly mention in passing. It's the 15th of April today, the day we're recording this podcast, and that is the release date of one Turanian Enigma.
Hey, well done.
It's out.
It's
out there.
Out there. Yeah, that's right. I forgot it was today. Well done. Congratulations. I did listen out for it on the media this morning, but...
Funnily enough, I'm going to have to sack my media manager. Because he sucks. He's really not good at his job.
Well, yes. He could be one and the same person.
I think he wants more money.
Oh, well, don't we all?
Yeah, we do. Anyway, that aside, but there are links to the sales page on the Space Nuts website if you'd like to have a look. Today, Fred, we're going to talk about the Event Horizon Telescope. We spoke about it previously when it imaged a black hole for the first time in history. I say image versus photograph because it didn't actually take a photo. It developed an image, I think is the way to put it. But now we're going back there because it's also providing us with a bit more data, this time in regard to a quasar. And I love this story. This is cute. We've talked about the next mission to Mars and the naming of the rover Perseverance. Well, Perseverance is going to have a fascinating passenger, which I imagine has also created all sorts of issues in terms of how do we make this thing work properly in an environment like Mars compared to doing the same thing on Earth. So we'll talk about that. And Peter has sent us a question about Earth's water. In one breath, he asks where it comes from, but he also has sort of sideline questions in regard to Earth's water. And Lance, I like this. This is a philosophical question, I think we could say, Fred. Lance wants to know how the discovery of intelligent life would impact on humanity. And I love his little example. If we found out on Sunday that there is intelligent life beyond Earth, would I have to go to work on Monday? I like it. So we'll.
Yeah, that's right. We can get to that in due course. We'll get to that.
One minor point, Lance. They still haven't found intelligent life on Earth yet. So Anyway, we'll get to those. But let's talk about Event Horizon and, of course, the infamous, or not infamous, the famous moment of the imaging of a black hole, which looked like exactly what we thought it would, a donut. Now it's focusing quite literally on quasars, or a quasar. What's the story? We better find out what a quasar is first, Fred, just for the people sitting opposite you.
We will. All right. Yeah, let's do that. I was going to talk about the observations, but let's talk about the quasars, because they've sort of that's been something that's kind of developed. Our theory and our understanding of what quasars are has developed throughout pretty well the whole of my career. Because when I started off, it was when the first observations of quasars were being made. Nobody knew what they were. The word is a contraction. It is from quasi-stellar radio source. That's where the word comes from. And why is it quasi-stellar? Because it looks like a point of light. In other words, it doesn't have any, you can't see any form to it, no galaxy or anything. It's just a point of light. And we really didn't know what these things were in the 60s and 70s. It turned out that they are very energetic. There is something about the way they beam their radiation, and I can explain it in this way. They vary in the intensity of the radiation that comes out, but they vary on a scale of hours. And that tells you that whatever the source is very compact, because otherwise that would be blurred out by the fact that the light would take longer to get from one side of it to the other if it's a big object. So variability on a short time scale tells you it's compact, and that was one of the first things that was discovered. And contrast that with the fact that by then we knew that they were at huge distances, what we would call cosmological distances, billions of light years away. And you do the sum, and what you discover is that these things are incredibly energetic. And for a long time, people had no idea where that energy came from. Now we know it comes about because quasars are in the centers of galaxies, and they are basically to do with the supermassive black hole at the center of the galaxy. And so what you've got to think about basically quasars are extinct today. There aren't any. Oh. So all the ones we see
are historical.
Looking back in time. That's right. And it goes back to a time when there was much more gas and dust and debris lurking in the centers of these galaxies. So there was plenty of stuff for the black hole to feed on. And the swirling accretion disk around the black hole, as we now understand, yes, that is driven to a frenzy of energy by the gravitational pull of the black hole. But what then happens is that the magnetic field of the black hole essentially focuses that material up its north and south pole. If you think of the equator as being where the accretion disk is, the north and south pole is where this stuff is squirted out. So we know that quasars emit jets of material, which is highly radiative. It sends out radio signals and is moving at nearly the speed of light. It's incredible stuff. The story itself of the quasars is a wonderful story. Thank you for giving me the opportunity to tell it again.
That's okay. I'm just a bit sad that they're extinct.
Yeah. Yeah, that's right. You should be glad. If we had a quasar in the middle of our galaxy, we'd all be curtains straight away.
Oh, they're that powerful.
Oh, absolutely. Yeah, okay. They're big time stuff. So here's the up-to-date story. And we didn't know this when the news was announced back in, I think it was about this time last year, a bit earlier, January 2019, I think it was, of the first observation of a black hole event horizon in the galaxy M87 by the Event Horizon Telescope. What's the Event Horizon Telescope? It's an array of, I think it's 8 radio observatories on one hemisphere of the Earth. Sadly, the hemisphere they chose was not the one that includes all the Australian radio telescopes. So whilst radio astronomers were involved with, Australian radio astronomers were involved with this, they weren't playing an immediate role in terms of the observations. So The Event Horizon Telescope observed M87, released this astonishing picture of the black hole event horizon, which we talked about ad infinitum, as did the rest of the world's media. Great story.
Now that we've mentioned a black hole, we'll get 10 questions about them.
Yeah, that's all right. We can do it. We can handle that. We just send them to somebody else.
That's right.
So what we now know, however, is that other observations were made during that observing run back in 2017 when they collected the M87 data. And in fact, we suspect that they observed, in fact, we know that they observed the supermassive black hole in the center of our own galaxy, the object which we call Sagittarius A star. But we haven't seen a release of that yet. But what has now happened is some information on this quasar, which rejoices in the name of 3C279. That means it was discovered very early in the history of quasar. 3C is the third Cambridge catalogue of radio sources. It goes back, I think, to the 60s. So it's number 279 in that. So a bright emitter of radio radiation. And it turns out that 3C279, throughout all the time, the 50-odd years that it's been observed, has been very violently variable. Its intensity has gone up and down in a big way. And sometimes it's very bright, sometimes it's not. And that's across the whole spectrum, Andrew. It's radio waves, X-rays, visible light, the whole gig. So it turns out, though, that the Event Horizon Telescope people used it as a calibrator. They used this object because it's a known source of radio waves, and it's a quasar, which means it's effectively very, very compact. They used it to calibrate their Event Horizon Telescope, bringing together observations from these telescopes all over the one hemisphere of the Earth. And so using those calibration observations, people have now basically seen things in it. They've learned things from it. And what we've learned is that there is jets of material, as expected, because that's why it's such a strong emitter, squirting out of the poles of 3C279. And that those jets have been analysed by the Event Horizon Telescope. We can see that they basically form blobs, which is kind of what you'd expect. These, because it's varying so much in its intensity, that corresponds with blobs of stuff being shot out from the poles of the quasar by the magnetic fields of the black hole. And these have now been imaged in incredible detail at multiple wavelengths. So we've got images which have been released on the web. I encourage Space Nuts listeners to go and find them. It's pretty easy to find. And they're blobs of material, and you can kind of tell from them that it's probably coming out in a sort of wavy pattern. Yeah. That is almost certainly because of what we call precession. It's the thing wobbling on its axis slightly. It looks as though there is a rotating jet, basically, that is coming out, shaped by these magnetic shock waves. So really fantastic stuff, a lovely spin-off from the Event Horizon Telescope. The paper, I think, will be published very soon in Astronomy and Astrophysics, one of the leading journals. And I think the lead author is at the Max Planck Institute for Radio Astronomy, which is in Heidelberg, if I remember rightly. It's in Germany. And they did the work on this study. I think actually they operate a radio telescope, which was one of the EHT telescopes, the Event Horizon Telescopes. So it's natural that the authors should be coming from there. Great story.
Yes, indeed. Very, very good story. And I suppose we'll just keep learning from the Event Horizon Telescope, will we?
I'm sure there'll be more coming from it. I think what they did back in 2017, they had a major observing campaign. We're not really sure what they observed. We know they did the M87. We know they did 3C279 now. And we're pretty sure that they did Sagittarius A star. There might be other things as well that come out. So the key thing about this, just to close the loop here, Andrew, is that having a radio telescope the size of the Earth, effectively, which is what it's synthesizing, gives you very fine detail resolution. That's the crux of it. In fact, their minimum resolution is 20 micro arc seconds, 20 millionth of an arc second. An arc second is 1/3600th of a degree. It would, if you had a 20 micro arc second resolving telescope here in Sydney, we'd be able to read newsprint in Perth with it.
Wow.
And likewise, the same in the United States. If you had one in Washington, you'd probably be able to read newsprint in Los Angeles or something like that.
Yes.
It's that kind of scale.
Wow, that's amazing.
It's pretty impressive, isn't it?
It is very impressive. I love their logo too. I know we talk about logos from time to time, but it looks like a telescope, but it also looks like the Earth.
Looks like the Earth. It's very, very neat.
Clever.
Very neat indeed. Yeah.
Okay, you're listening to the Space Nuts podcast with Andrew Dunkley and Professor Fred Watson. Let's take a break from the show and hear a word or two from our sponsor, Grammarly. Now, I have to say I'm a big fan of Grammarly because I've been using it for a few years now. Very helpful for authors, but also really good for everyday life. They've saved me on a few occasions, particularly with spelling, but also with a few issues that didn't quite make sense. It's built by linguists and language lovers, and Grammarly's writing app finds and corrects hundreds of complex writing errors, so you don't have to do it yourself, word by word, day by day. You can easily copy and paste any English text into Grammarly's online text editor, or just install Grammarly's free browser extension for Chrome, Safari, Firefox and quite a few others. Grammarly's algorithms flag potential issues in the text and suggest context-specific corrections for grammar, spelling and vocabulary. Grammarly explains the reasoning behind each correction so you can make an informed decision about whether and how to correct an issue. Grammarly helps you write mistake-free Gmail, Facebook, Twitter, LinkedIn and nearly anything else you write on the web. For you, the listener of Space Nuts, Grammarly is offering a free download of the Grammarly software. So if you'd like to download Grammarly today, go to getgrammarly.com/spacenuts. Again, that's getgrammarly.com/spacenuts to download Grammarly for free and let them know you came from us. I'll include the link in the show notes as well. And now, back to Space Nuts.
Space Nuts.
Now, as you know, we have a Patreon page because we were asked more than a few times by audience members how they can support Space Nuts. And so we created the Patreon Space Nuts page so that you could take advantage of that opportunity. And by coming on board as a patron, we'll give you access to the commercial-free version of the show. You'll get the occasional shout-out. I think we've actually been doing that every week. You'll be able to access merchandise giveaways ultimately, and there is bonus material that we throw in. So if a patron asks a question, the patrons themselves get the answer on the Patreon page. So if you would like to become a patron, we're on the march to 500 patrons. You can do that at patreon.com/spacenuts. You can set your own figure. It is not mandatory. We do not expect you to do this. It is purely voluntary, and those of you who have chosen to do so are forever in our debt, or we're forever in yours. Or, I don't know. But thank you is what I'm trying to say. Now, Fred, let's go to my happy place. Let's go to Mars. I love this story. I talked about this on the radio yesterday because obviously the headline caught me, and I was very excited to hear this. And I know we've talked about the Perseverance rover when it got named by, I think it was a 14-year-old school student in the United States. Now the rover is going to carry a little buddy to the surface of Mars. Right. And this thing won't be a rover. This will be something else.
Indeed. The first extraterrestrial helicopter. The first helicopter to fly on another world.
That's amazing. Yeah.
It is. It's fantastic, isn't it? It's great stuff. Why is this in the news? Just to put it into context, I think about a week ago, the helicopter was actually attached to Perseverance which is currently under final preparations at Jet Propulsion Laboratory in Pasadena. The helicopter, slightly counterintuitively, is carried on the underneath of the rover.
Oh, really?
Yeah.
That seems at odds with what you need to do to launch a helicopter.
I'm assuming that to deploy it's probably it's the best way, really, when you think about it. It's on the underneath of the rover. When it's deployed, it'll be deployed under the rover, which will then move away so that the helicopter is essentially ready for flight.
I can see a potential problem here already. No. What if they put it on a rock and it falls over?
Yeah, that's right. And there's a wire dangling down that just drags the helicopter around with the rope.
Runs over a rotor.
I think it works better. Well, look, these
I'm
guys,
sure they've covered all that.
They're pretty cluey. So at the moment, it is underneath with its rotors sort of stowed. Just to give you an idea of what it's like, it's kind of about the size and shape of a ceiling fan.
Oh, okay.
And I could see one right over your head.
Yeah, I've got one in this room for hot summer nights.
So it's got two rotor blades, but they rotate in opposite directions. Unlike a ceiling fan, the rotors actually turn in opposite directions. Of course, that is so there's no residual torque on the helicopter. It's so that the helicopter itself stays put. It's the dual rotor form of helicopter rather than a tail rotor, which would counteract the rotation, the torque canceller. Yeah. As most of the helicopters.
I suppose that means it can be more compact as well. You don't have to have these extra bits sticking out all over the place.
Yeah, indeed, that's exactly right. But it's just a lovely piece of kit. Of course, the key here, Andrew, and this is the question on your lips, I'm sure, is how do you make a helicopter work in atmospheric pressure that's about 1% of what we have here on Earth?
Exactly what I was going to say, because and I was talking about it yesterday on air and saying, how can they test it when our conditions are so very, very different? So you couldn't test it on Earth because it wouldn't do here what it will do there. So how did this sort of get sorted out?
So, well, you can do half of it. I mean, the two big problems are, first of all, reduced atmospheric pressure, but also reduced gravity, which, of course, helps you counteract the reduced atmospheric pressure. So you can deal with one of those because you can test it out in a huge vacuum chamber, pump it down to the pressure on Mars and fly your helicopter around, and that's been done to death. I think they've done many tests. What you're doing though there is testing in Earth gravity, and Mars gravity is about a third of the gravity on Earth, so that all has to be built into the calculations as well. But I think the owners and operators of the helicopter are very confident that this is going to work a treat. Actually, I don't think it's got a name yet. I don't know whether it's got, I'm sure it will end up with a name. It'll have to, because it'll be tweeting like all these spacecraft.
Maybe they'll have another competition to see if someone can come up with a
name. Maybe not. Or maybe Perseverance B or something like that, which is a slightly...
That's pretty ordinary. Sorry.
Yeah, it's pretty hopeless, isn't it? Yeah.
That's why astronomers should never name anything.
Yeah. Our name would be Perseverance 1, 2, 12, 76 plus 9.
Probably.
Anyway, it's been assembled with the spacecraft. We look forward to seeing it again on Mars. Just a word though about what it'll do. It's not.
That's my next question.
Yeah.
Why am I here?
Why is it there? That's right.
Now, why am I here? Because you keep asking the questions.
Oh, I see what you're saying. Yeah. Well, you're there because you're the anchor man, Andrew. Right. Without you, this would not fly. Neither would the helicopter.
Well, if I'm an anchor man, it won't fly, will it?
I'm not quite sure which one of us is the straight man, but that's all right.
That'll do.
Yeah, that'll do. All right. Okay, so it is flying in advance of the rover. That's why it's there. It's not there particularly to take data. It will have sensors on board, of course, and cameras, transmitters, all the rest of it. I'm not sure how it's powered, Andrew.
I'm going to guess battery or maybe solar chargeable batteries. Although they'd be heavy, wouldn't they?
There may be solar panels on the rotors, I think, but I've got a feeling I'm not sure about this. I remember thinking back now a year ago when this was first talked about, whether it might be, or maybe one of the schemes was that it will come back to the mothership, the rover itself, and get a recharge. That means it's got to somehow land in such a way that it can actually pick up electricity from that. That can be done, as we know, by induction, so it might not need to plug anything in. I'm not sure of the details of that, but I will find out. But looking at the pictures, I suspect it does have solar panels on the part of the rotor tops. It is its whole purpose is to be able to fly over ridges, to fly over hills, just to have a look at what's ahead, so that the mission controllers operating the rover can actually work out the best sites to go, perhaps the easiest route to get them to a different part of the surface of Mars, perhaps spotting interesting looking rocks and things of that sort. Remembering that Perseverance, its whole raison d'etre, the reason for this mission, is in order to find out whether Mars ever had life. That's the underlying theme, and it's the first spacecraft really that we've sent to do that. At least in the modern era, it is. A couple of early things had that in mind, but didn't quite get there. So unlike Curiosity, which was to find out whether Mars was ever habitable, and did very quickly, Perseverance is there to find out whether Mars was ever inhabited, and we all hope it'll be as quick as well. But the helicopter is going to help in this process, because the having an overhead view, I can't remember how high it flies. It's a couple of 100 meters or something like that, I think. I mean, it's not a small object. It weighs, if I remember rightly, 1.8 kilograms. It's a fairly hefty piece of kit to fly around Mars, and so its job is well, it's well defined. It will, we hope, hunt out likely looking places to find fossil remnants of creatures that may have existed on Mars.
Yes. Now we're talking a launch in, is it July, with a potential landing in early 2021?
Yeah, if I remember rightly, it was the 18th of February, the landing day. I can't remember, but I think it's about then. But the launch is planned for July or August this year, and I'm sure that will go ahead. There's a 3-week window because, of course, with Mars, what you've got to do, if you're sending things to Mars, you've got to wait till the Earth and Mars are in exactly the right relative position. Yeah. You can't just set off any time. The window's 3 weeks, opens up on July the 17th this year. So
I'm looking at a close-up photograph of the helicopter, and yes, it's got the 2 rotors which spin in opposing directions, but above that it looks like a solar panel.
Yeah.
Could be a solar panel.
That sounds about right.
So that would explain that.
Yeah. There is another...
O'Reilly! It's Superstart Battery Month at O'Reilly Auto Parts. Get up to a $25 gift card after rebate with the purchase of select Superstart batteries. Our professional parts people will test your old battery for free and recommend the right battery for your vehicle. For power, performance, and reliability, choose Superstart batteries only at O'Reilly Auto Parts. O'Reilly Auto Parts.
Another interesting aspect, and this might be another reason why it's sitting underneath the rover Perseverance. I think it's 2.5 months after Perseverance touches down that they will deploy the helicopter.
Yeah. So it's going to be, and they don't want it to get covered in dust or...
Well, I don't know. Yeah, I don't know whether they'd dump it somewhere and then come back to it, or carry it around for 2.5 months. I mean, Perseverance itself will probably have a very limited set of excursions during that time, because everything has to be checked out. And indeed, the helicopter itself has got a 30-day test campaign as well that's down the track. So Oh, it's great stuff, Andrew, and I look forward to you and I talking about it next year when all this happens.
Yeah, I can't wait. Can't wait.
Deployment in May 2021. They expect
and the landing date is February 18th, and and we've got to remember this rover is not small; it's about the size of a car, from what I've read.
Yes, it is. So, the rover itself.
Carrying a bit of a helicopter under there is probably not that big a deal. And, with all this technology, I've just found out how they're going to attach the helicopter to the underside of the rover. They're going to use blue tack.
I actually thought they were going to nail it on just to make sure it didn't fall off.
Use those rust-free rivets.
Yeah, that's right. Well, there's no rust on. Well, there is. The whole of Mars is rusty. Actually, that's why
it is, isn't it?
But I was going to say no rust on Mars.
Yeah. All right.
Anyway, great stuff.
This is a story we will definitely be pursuing.
We will, and we wish the mission well. We hope everybody keeps safe who's working on the rover. And
I suppose we should also say that they're doing well, considering that a lot of NASA projects have had to be hauled back and slowed down due to COVID-19. So they're going to get on with this one, and they're just about ready, just doing some tweaking. So we'll keep an eye on that one, Fred. Indeed. You're listening to the Space Nuts podcast, episode 198, with Andrew Dunkley and Fred Watson. And boy, are we tired.
0G, and I feel fine.
Space Nuts.
Now, Fred, big hello to all our social media followers. That includes our YouTubers. We've got 1,200 YouTube followers now, which is fantastic. That's a great number. And I imagine, given those sorts of numbers, there are a lot of people following us on YouTube that don't follow us on Facebook, because the number variations are quite significant. So we've got some new followers on the YouTube channel. So Space Nuts on YouTube is youtube.com/c/Space Nuts if you want to become a YouTube follower of the podcast. Or you can stick to standard social media and follow us on Facebook, Twitter, Instagram, and you can also join the Space Nuts podcast group on Facebook. That's a group that was the idea of a listener and sort of went from strength to strength, and that's where you as a Space Nuts follower can also engage with other Space Nuts followers. We all call ourselves nutters, I think. So if you would like to partake in that, you're more than welcome to do so, and enjoy the company of like-minded people. Now, Fred, we've got some questions to deal with. Love this one from Peter Hindwood. He says, "Hi, Fred and Andrew. I was wondering if you could explain how Earth received all its water. Where did it come from, and when did it arrive?" It was a freight shipment, and they put it in the wrong place, and we didn't find it for millions of years. Also, in my imagination, what would have happened if Earth had received so much water that there was no dry land and was truly a giant water planet? Would it have stayed in its current orbit? Best regards, Peter Hindwood. Hindwood, I'm going with. Good question, Peter. Love the second part of that question. We have actually, Fred, talked about how Earth received all its water before, but I think we can revisit that. Comets and asteroids and the like.
Yeah, mainly, though, it is still, to some extent, an open question, Andrew. There are differing bodies of opinion. I guess what is still the foremost theory is that in the early history of the Earth, when the solar system was wild and woolly with everything colliding with everything else, there were influxes of comets from the outer solar system, which basically collided with Earth. Now, we know that comets have collided with Earth in the past. We think, actually, that the Tunguska object was probably a comet. May not have been, but probably. So what are comets? They're basically huge mountain-sized or mountain range-sized bodies of ice, mostly ice, water ice, with a lot of dust and stuff in with them, sort of locked up in the ice. And that's why when comets get near the sun, you get a dust tail and a plasma tail, because of the fact that the ice sublimes. It turns from solid into gas. We think they all come from something called the Oort cloud way, way out in the depths of the solar system, which is sort of the last vestiges of the cloud in which the solar system was formed.
We think they come from there, but we ought to know, Fred.
We ought to know, yeah.
Sorry, all right. I had to do it.
Well, let me put it this way. The evidence points to the fact that they come from there. How's that?
There's always room for dad jokes in Space Nuts.
All evidence is based. Well, that's right. In fact, the whole thing's a dad joke, really. Or is it a dud joke? I don't know.
Be both.
Yeah, good for both. So, yes, comets have played a role in the entire history of the solar system. And perhaps the most popular theory says that the early Earth was bombarded by comets coming from these regions rich in water ice. And it's possible to show that they would have been able to deliver enough water to fulfill the oceans of the Earth. One of the problems with that is the isotopic content of the water. It's a mix between heavy water and normal water. Heavy water's got deuterium in it rather than normal hydrogen. And you and I had a conversation about this, I don't know, 6 months or so ago, because we got stuck on the idea of whether you could drink heavy water and whether it would kill you. And indeed, we both did our bits of research and found that, yes, you could drink heavy water, and if you drank it for long enough, it would kill you,
yes.
but not immediately. Anyway, so, okay, the issue is that the comets that have so far been directly investigated by spacecraft, and there's, I don't know, it's 3 or 4 of them, I think, including Churyumov-Gerasimenko, the one that was visited by Rosetta a few years ago, some of them, not all of them, seem to have a different isotopic content in their ice. In other words, the proportion of heavy water to normal water is different in comets from what it is here on Earth. And that has been raised as a possible showstopper for the idea that water came from the comets. But there are some other comets that have been observed that actually have the same isotopic composition. So it may not be a showstopper. Meanwhile, some other scientists have suggested that the water that is now in the oceans basically arrived locked up in the original dust clouds that the Earth was formed from. So it was, it's like hydrated dust particles, and that's where the water comes from. It's a lot harder to get your head around that, how that then turned into liquid water. So just for Peter, the origin of the Earth's water is still an open question, but it is a really interesting one, and it fascinates planetary scientists, and hopefully will eventually have a more solid answer than we have at the moment. Yes. Now, the second part of Peter's question is...
Well, this is the fun part.
Yeah, it's the fun part. What if there was no dry land and the Earth was a water planet? Would it have stayed in its current orbit? And the answer is yes, it did, because it probably was once a water planet. There is evidence, there's a few stories, if you look back, on the web, a number of different studies have arrived at this idea. The most recent one I found came out actually very recently, in fact, only this year. This is some work that comes from rocks here in Australia, actually. It's published...
There's no water here, Fred.
No, the driest continent with the evidence that once the Earth was covered in water. Once again, these rocks are in northwestern Australia. It's a slab of rock which was once ocean floor, and apparently it's now turned on its side. It's in the Panorama district, northwestern Australia's outback. And this rock is 3.2 billion years old. Remember, the Earth's 4.6 billion years old, so it's still dates from a time that's not back to the beginning. But there is evidence within that rock, and it's once again to do with isotope ratios. It's actually oxygen isotope ratios that suggest that there were no continents. In other words, the Earth was basically covered in ocean. So one of the scientists, this is work that's been done at the University of Colorado in Boulder, And actually, there's one of the collaborators is Iowa State University. That's someone called Benjamin Johnson. He says, without continent, let me just backtrack a bit. They think that the reason why they think there were no continents is because the clays that were found on what was the ocean floor have this particular characteristic that it absorbed the particular isotopes of oxygen. So what Benjamin Johnson says is, without continents above the ocean, the oxygen value will be distinct from today, which is exactly what we found. And it's different in a way that's most easily explained without land to get rained on and without soil formation. So what they're saying is that the large-scale continental, the large-scale continents that we see today weren't there, but they don't rule out the idea of microcontinents, little, perhaps volcanoes poking up above the ocean surface. Yeah, and one of the Boswell Wing is the other leader of this project. Yeah, he says, I imagine a picture of kind of like what must look like to approach the Galapagos Islands from the west. Well, I've done that, so I know what it looks like. Vast expanses of ocean waters to the north and south, with small volcanic rocky islets barely poking above the ocean surface. Okay. So you've got this, idea of a wet world with a few little things poking up through it. 3.2 billion years ago.
So what changed that created the continents? Was it just seismic shifts?
The whole, the large-scale changes of the Earth's history have included a snowball Earth when the Earth was completely frozen. And it's all about the way the atmosphere behaved. The orbit does have changes in it over geological time, but the orbit of the Earth is basically very stable. It's more the atmospheric conditions that change, that cause these dramatic differences. So that really the last part of Peter's question. Would it have stayed in its current orbit? Yes. Changing the Earth to a water world doesn't really have much effect on the planet as a whole, because we're only talking about the surface rather than the interior. The interior has been pretty constant for 4.6 billion years.
Okay. There you go, Peter. Very good. Great question. Fun to try and crack that one. And we'll move on now to a question from Lance Herring, and he says, hello, Space Nuts. First off, thank you so much for your podcast. I truly enjoy it. Oh, there's one. Quick question for the two of you. What do you think the response from humanity will be to the announcement that finding life on another planet? Do you think the response would be different if we find intelligent life? And if so, how? And I mean, if we found out on Sunday that there's intelligent life beyond Earth, am I going to go to work on Monday? It's a great question. Thank you, Lance.
Yeah. It depends what they're doing. If they're...
I might just preempt you here, Fred, if you don't mind, but I think a lot of the reaction we would see, pointing to the second half of Lance's question, would be what was portrayed in the movie Contact. I think that Jodie Foster film, where they did actually contact intelligent life beyond Earth, I think the way the world would react would be pretty close to that. Just the way the world is reacting to COVID-19 was portrayed in the movie Contagion. I think the world's reaction to such a discovery would be pretty close to what they did in that film Contact.
Yeah, actually, I'd also put up a vote for Arrival, which
which got very military, didn't it?
Yeah, it did. But the whole, these were benign aliens in Arrival.
Yeah. And they came asking for us to help them, as it turned out.
Yes, that's right. So, and the whole point about was it was Amy Adams' character, who was the linguist who eventually interpreted what they were trying to say to us. Well, or whatever. I think all those things are probably they're probably good pointers. the answer basically to the question what the response from humanity will be is that there are protocols which have been in place for about 30 years. One of the scientists who worked on this is Seth Shostak, who's with the...
I know that name.
Yeah, SETI Institute. He's well known in the SETI Institute. I had a chance to have a good chat with him. It's now, it's nearly 20 years ago, 2003, because he was here for the International Astronomical Union's get-together in Sydney in 2003, and really interesting guy to talk to. He was really, inspiring to speak with. So what he says is, there are some protocols, but I think that's an unfortunate name and makes them sound more important than they are. In the 1990s, he chaired a committee of the International Academy of Astronautics that prepared a revised version of the detection protocols for researchers who watch for possible alien transmissions in the field of SETI. That's basically a quote not from Seth, but from Life Science. So the idea was that these protocols are guidelines, as Seth Shostak explains. Seth Shostak SETI. You've got to make sure you don't get those three words mixed up. He explains that they were set up for governments and scientists rather than as a kind of action plan. That's the way he put it. And there's a quote from him here. They say that the protocols say, if you pick up a signal, check it out, tell everybody, but don't broadcast any replies without international consultation, whatever that means, he said. But that's all the protocols say, and they have no force of law. The United Nations took a copy of the early protocols and put them in a file drawer somewhere, and that's as official as they ever got. So it's really interesting that I guess governments are thinking detection of any sort of SETI signal is so unlikely that we really have far too many other things to think about rather than the United Nations response to what you should do.
We have at the moment.
Yes,
Indeed.
Yes, exactly. So it is a moot point about what would happen. I mean, certainly I remember people talking back in the 80s, you can't, if we find a signal, you simply cannot tell the public. But that doesn't hold good in the 2020s partly because we're all so interconnected. Social media would have that out there.
Oh, for sure.
In no time at all.
Conspiracy theorists think we already have received signals.
They do.
It's
that's
already
right.
been here, and etc.
Yeah.
I think we've already witnessed the world reaction to this in one respect when they found that rock with bacterial evidence on it that they thought came from Mars. And Bill Clinton actually made a public announcement about it.
Did.
So I think we've actually seen how people would react.
He did. That's yes. So we are talking about two different things here. That's the existence of life beyond the Earth,
yes,
rather than any intelligent species.
Yeah.
So what Seth's talking about is very much the intelligent life. Now, turning to the other question, which of course again is part of Lance's question. You're absolutely right. That was the Allen Hills meteorite. And Bill Clinton announced that, I think, on the eve of his re-election. I think it was on the eve of the poll. And so it was not the best concealed plug.
It was a stunt. It was a stunt, mate.
Yeah. What's that about? That is about a meteorite that was found in Antarctica in, I think, 1980. It contains structures within it which look at first sight like microbial structures, except they're 1,000 times smaller than most microbes. They're very, very small. And whilst they look like microbes, there's nothing else about them that suggests that they are. So the criticisms that were thrown at the Allen Hills meteorite, the people who believed that they'd seen evidence of Martian life there, one was that these things could have been geologically caused, and that actually is the current view, that they're from geological processes rather than life processes, or that whatever these things are, they could have been picked up during however long it was on Earth. I mean, I think this spacecraft this meteorite probably sat in Antarctica for quite a long time before it was found. And so there could have been some sort of microbial contamination, although in Antarctica that's less likely than it would be elsewhere on Earth. How do we know it came from Mars? There's a whole suite of, I think there's about 200. Yeah, 200 meteorites, almost like that we know came from Mars, and about a similar number that we know came from the Moon. The Mars ones are identified because we have samples of the Martian atmosphere, which were made back in the Viking days, actually, which tell us that the atmosphere of Mars has certain constituents which are present in these meteorites. So Alan Hill's meteorite, definitely from Mars, but probably not containing life. But exactly as you've said, we do have a picture of what the reaction would have been. And it wasn't that, it wasn't that overwhelming.
No, it wasn't. No, we sort of took it in our stride. And I reckon that's what would happen again, because we're kind of reaching a point where we're expecting this to happen now.
We're certainly expecting microbial life, yeah. I mean, who knows what might come back from Perseverance within the next few years. And that is set up to measure life or to detect life on Mars. So I think it's more likely to detect past life on Mars, but you never know. Could find a few extremophiles under the surface there.
So sadly, Lance, regardless of what kind of life there is, you will have to go to work on Monday.
That's the bottom line. Yes. That's right.
And going back to Bill Clinton's statement about the potential for life having been found on Mars, it did actually prove to be a very useful statement because they used it in the movie Contact. So his statement was used to demonstrate the reaction to the world to the discovery of intelligent life beyond Earth. So it was very cleverly sort of slotted into the film. It's great movie. Really love it. Yeah. Thank you, Lance. Great question. Great fun trying to sort that one out. But I think we've reached a point where finding microbial life will sort of, we knew it was there. And that was that. But intelligent life, that could be a different ball game. We're going to leave it there. Fred, thank you so much. It's always great fun. Good fun, Andrew, and look forward to the next time. Indeed. And don't forget the Space Nuts shop at bytes.com/space nuts, where you'll find all caps and mugs and polo shirts and T-shirts and stickers and books. There's a new one out today, apparently, that we've got a funny name. I was going to mention it, but you've done it for me. Yes, never let a chance go by. Tell us again what it's called, Andrew. The Turanian Enigma. Ah, what a name. I love the Enigma bit. I do too. Yeah. Yes. Thanks, Fred. See you next week. See you soon. Take care. Bye-bye. Fred Watson, astronomer at large. He'll be back next week, and so will I, Andrew Dunkley, bidding you farewell. Buy my book, and we'll catch you on the next edition of Space Nuts. Oh, Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favourite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.